Intel, which is not the case. That's how you and I have known each other for a very long time. But you're now with FADU. You've been in the industry forever. You know more about Flash than most people. So this will be an interesting conversation. How are things going over there?
I was gonna say last time we caught up, it was with some Topo Chico. I had to go find one. Yeah, I had to go find one from the fridge to make sure we were aligned. No, yeah,
Good.
last time we caught up was about Chia and blockchain crypto stuff, which is, you know, crypto craze is still kind of going, but I'm back in the SSD world.
Well, yeah, I don't know. I
Yeah.
mean, you brought it up, the crypto
Okay.
thing. What's going on with that? I know
Uh,
Chia was fun for a while. Is it still as
yeah,
entertaining?
everything's. Yeah, a lot of these projects just take a long time. You know, it wasn't a great IPO market or a great crypto market the last 2 years, and so just like it was actually weird timing because the storage market was getting just pummeled too, right? It was like 6 quarters of absolute pain, and so yeah, I went back to tech here like late in the fall, kind of early or like earlier in the year, and then it's just like the AI just you know like jump started the SSD market back to life, like
Well,
overnight. 50% increase back to normal, and then it went from being like the worst year ever to potentially the best year ever for SSD revenue. It's like
well, it helped
uh,
that though that like
yeah,
during COVID, the NAND prices got absolutely destroyed for a long period of time. Clearly, they've been on the way back up the last 6 or 8 months. Anyone
yeah.
who's had to buy SSDs will tell you that. I've heard more complaining in the last month about SSD prices than I'd heard in the 3 years prior. So this is a renewed, fresh pain, I guess, for people that aren't used to the
Yeah.
cycles of the ups and downs of NAND.
Yeah, I mean, everybody, like WD has their big like AI data cycle. Solidigm's obviously been talking about these different
Yep.
stages for the AI life cycle. Like every company is basically seeing this impact in a different way, but it's obvious like just the more money that is spent on capex for data centers, like they're going to need more flash. What percentage is it of total capex? We don't know, but it's a lot more than it was. It's going to be. Yeah, even though storage is kind of like the unsung hero of AI, nobody really cares about it until something breaks or something gets slowed down or the GPUs aren't being utilized fully.
Well, I mean, so you hit on like six different points there, and we should dive into this a little bit more. Storage, the feedback we're getting and the projects we're getting asked to engage on are to highlight how storage is important to this AI journey because you're right, the storage isn't a problem until it is, but legacy SAN infrastructure is not necessarily ready to fuel super high-end AI GPU work. And I guess we've got to make some delineation here, right, between AI that's in a 2U server with two L40Ss in it versus racks and racks and racks of eight-way systems per rack and liquid
Yeah,
loops and all this other thing. That's a different thing. The pictures we've been showing of
yeah,
X's
it's
data
actually
center is different.
yeah. One of the cool things that I saw, the meta engineering has been really good about like putting out blog posts about kind of what they're doing, and they actually shared a lot of information on their website about what they're doing with the storage on their two 25,000 H100 clusters that they trained Llama 3 on. Right? They mentioned that they're building exabyte scale already just for these clusters, so exabytes of flash extra just for these clusters. They mentioned that they're doing it all over like 400 gig Ethernet or InfiniBand. And so they have this disaggregated storage box. They mentioned it's kind of like Yosemite V 3.5 that they
Yep.
have in OCP. It's like more drives, disaggregated storage. But this move where they're going they're shifting from like 4 terabytes to 8 terabytes now to 16 terabytes in this disaggregated storage tier just because they need a lot more flash capacity for training these large multimodal models. But like, um, and then you have like the fast SSDs like inside the training servers, which is just obvious. Like you want Gen 5, you want the fastest fastest interface because you're dumping these
Sure.
checkpoints super fast. You just want fast sequential write, good random read for these training. Um, but yeah, it's still like if you look at like one of these H100 HGX systems, right? Eight H100s. I mean, the system costs I don't know, somewhere between $270 and $300,000 if you buy it from like a distributor. Like, so even the 8 SSDs in there is like 3 or 4% of the total cost of the server. It's very small, right? So, you know, going high end on the SSDs Gen 5 is not, it's not going to like significantly increase the cost of these training servers.
Well, it's almost more of a capacity play at that point, right? Getting as much storage in that cache in the GPU server as you can is part of it. But then there's all sorts of other technologies, like WD's been demonstrating their NVMe over Fabrics OpenFlex chassis that's designed to try to get these storage drives via GPU Direct adjacent to the GPUs. Then there's everyone else with a parallel file system out there talking about, you know, the Weka guys, DDN, Vast Data, all talking about these things. But I think all this stuff confuses the issue at times because, again, AI is not a monolithic singular thing. Have you guys spent some time thinking about what those different parts of AI look like or the workflows there?
Yeah, and it's funny. I just joined like the ML Commons, like the storage benchmark stuff, and I'm starting around messing around with like some of these AI storage benchmarks. Like, look, I spent a bunch of time doing benchmarking on inference, just to see like, hey, is there anything storage intensive there? And it's like, when you're doing inferencing, there's zero storage. It's all running from GPU VRAM. Like, even if you go to system DRAM, it's like 10 times slower. So, like, the only storage you need in inferencing right now is just loading the model. Now, I think people are figuring out that these RAG systems are really interesting, right? Instead of just giving everything into a prompt in one giant context window, like, it's just better just to have the data right next to it in a database, and then let the systems are going to get smarter about just deciding, okay, let's look up where that data is in this RAG, and then use that for the prompts. And so those workloads are just going to look exactly like we have for databases already, like the NoSQL databases that we already have, and it's just going to be like, you want sequential write, you know, good random read performance, good quality service during random reads. It's like everything that we've already done for optimizing for databases, for hyperscale databases and SQL databases. Like for RAG, that's just going to be already there and built in. So that's awesome. Like, we don't have to do anything else. You know, I've talked to a bunch of folks about this checkpointing, you know, whether or not, like, okay, is it just done locally to the server, or do you guys do it over this NFS? Or do you know, it just depends, right? Like the answers we got were like very different. Like some people will checkpoint more frequently because they're training a model where they don't want to lose a bunch of GPU cycles, and it's actually not very expensive to go just take a bunch of checkpoints, and then if you need to roll back a day or two, it's no big deal. And it's funny, they've been doing this in the HPC world for ages, right? Like when I remember actually one of the very first like SSDs we worked on was this, you know, PCIe by 8 add-in card, and I remember like Cray was actually the first one to use it for HPC. Like, they use it as this thing called a burst buffer, like where they're just dumping the DRAM into flash, like, you know, periodically to basically checkpoint these HPC systems. Like AI training workloads are exactly the same thing. Like, so at some point, you know, some people checkpoint, is it every 10 minutes? Is it every 1 minute? Like, as the models get bigger, you need a lot more bandwidth to checkpoint. Do you do it on an array? Do you do it on, you know, locally before? And, you know, it just depends on some, like, I'm sure like even within one company, they might have different checkpointing stuff for a bunch of different model types. And, you know, so all I know so far from all my research is fast drive, good.
Fast drive or big, I guess, depending on what you're doing too, because that's the other bit.
Well,
So,
the big one is interesting, right? Because it's funny, we were talking about the SSD market like being crashed like last year. It's funny, it got to the point where QLC was like, even TLC was like 3 times the price of a hard drive. Like it, and that was when we did all these. When we wrote the SNIA TCO model, that was like the golden crossover. If you could get to like 2.5 to 3x the ASP per gigabyte, like almost all the TCO models just crossed over for for all storage use cases for flash versus hard drive. But then it bounced back up, and now it's like over, you know, back over 10x. But another phenomena is happening where the data centers are running out of power.
Yeah.
Like, I mean, everybody's trying to secure 5 megawatt, 10 megawatt, 100 megawatt data centers. They're talking about gigawatt data centers now to train these models. And eventually, like, they're going to figure out that, like, oh, yes, if we can save 3 or 4x on the power and storage, like who cares about storage? Yeah, just go to the more expensive drives. Like, if we can reduce the power, because you need all the power you can get. So I do think that's happening, and it's going to come. There are other use cases for big drives, just that the fact that they're bigger and you don't need a bunch of network bandwidth. You can have a bunch of stuff local to the server and cache a bunch of the training models there, so you don't have to keep grabbing it from the network. So a lot of data centers don't have like fancy 400 gig or 800 gig networking. They have like old shitty networking. Right?
No, I mean we got Broadcom sent us 400 gig NICs this week or last week, and those are the first real high speed NICs we've gotten in. And you talk to people and they're like, well, my array's 100 gig Ethernet end to end. It should be able to fuel anything. And it's like, well, no, because when you start passing that over the wire, it's really not all that fast. Even 40 gigs. So we've got a server, one of these, this Supermicro over my shoulder here, this E3S server. It's got 2 OCP slots, and now Broadcom's got single port 400 gig cards that we can drop in there and get 40 gig a second out each port. So now we got 80 gig out of the box, which now starts to make it much more useful from a whatever you want to do with it. If you want to feed a GPU server or be a high-speed cache for data to feed the GPUs, but lots of opportunities there.
There's a reason why these, when you look at when you get a quote for one of these 8x HGX systems with H100s, they come with 8 400 gig NICs. You just need if you're building big GPU clusters, you need crazy network bandwidth.
Well, so you started talking about how AI has driven storage re-awareness, right? Everyone's got to rethink their capabilities, their capacity, their backup plan. What do you want to keep? What do you want to protect? But the switching business is fired up too, because I don't know how many people you talk to. I talk to them all the time, where they're at 1025, and they think they're cruising along because they're used to just serving up business apps. Now, these guys aren't the guys that are going to put, a rack of 8 of these $300,000 systems to work for training. But even if you pick up a pre-trained model and then apply your data to it, there's still a pretty heavy lift at moving stuff around and even keeping, a relatively benign 2U server with a couple GPUs in it going. Switching now is a real big part of that.
It's actually amazing. I talk to a lot of companies, like even some of these SSD companies, and you're like, okay, in your DevOps, how many GPU servers do you have? And a lot of these guys are like, none.
Yeah.
It's like that is, it's not the right answer for this AI stuff. You can't just rely on external APIs. I mean, my basic benchmarking shows that you can get 1/20th the price of OpenAI per token on an open source model fairly easily without tweaking or optimizing very much. But the real value, obviously, of running these GPUs locally is having your private data sets, because a lot of companies aren't just going to dump all their stuff in AWS and be like, okay, we can do RAG on that. But it's we're moving to this space. Obviously, it's going to add a bunch of value. People are going to want their data sets in these available to these AI models, right? It would be stupid not to. Other companies are going to do it, and they're going to have a competitive advantage.
Well, even going to the cloud though isn't the easiest option, because we were hearing early on there was Oracle bare metal had the A100 and later H100 8-way boxes. There were a couple others, but it's not like you can just show up and get a month on those things. They're big contracts. They're not simple consume for a little while and turn it off kind of deals, because obviously those cloud guys are having to make big investments, and it depends on where you are too. So, just a reminder for the audience, if you're catching this later, we shot this thing live. So we're live right now, and we're getting a lot of great comments on YouTube, Discord, and all of our social media platforms. But one, Gabriel Ferraz is checking in from Brazil. Gabriel, thanks for following along. JM, do you see any, as you look at the global markets and you work for a global company now, do you guys see any trends that are different in what we're used to in North America versus what something that they would see in Brazil or South America or Europe or Asia? Are there different things happening in different global regions?
Sorry, I had to take a second to go on the Discord and like your post that you put.
Discord.gg/storage review. If you guys aren't in there, get in there.
I am there. You guys can tag me and yell at me if you need to ask questions.
I wouldn't invite that, but now you have, so that's your fault.
the lab pillagers and such.
Yes.
No, I mean, like I said, it's probably similar. Like I think all these companies, you just see like these like the McKinseys of the world and these consulting Accenture just making like hundreds of thousands of dollars just to like help basic companies like figure out like AI stuff. Like it's honestly not that complicated. You just need to get some GPUs. You need to play around with some stuff running. Like these RAG stuff, even 3 or 4 months ago, it was like very complicated to set up. I ran one like last weekend in the NVIDIA, whatever they had, like their AI studio. It just spins up a Docker and it launches you a little Chrome app that has RAG right there. You just upload a file or a folder and it will convert it to a vector database, and then you can use their endpoint or your, like, this is not like super complicated stuff, but it is, the whole AI stuff is kind of clunky right now. But I think a lot of the companies are in this same spot where they're just like, we know we need an AI strategy. We don't really know what that is. Like we should be using these tools. OpenAI and these guys are going to be pitching these enterprise plans that are private and don't leak your data, and you have to hook up AWS to it and stuff. Sure, you can do that. It's going to cost you 20 times more than figuring out yourself. So,
well, it's funny you mentioned RAG because we actually did a piece, and I'll put it in the notes on YouTube. But we set up a QNAP NAS with a A4000 and ran the RAG on there from NVIDIA. I've lost the name. It was a Chat GPT kind of thing.
Yeah.
Anyway, you can run it against your private data. So if you've got a little NAS like a QNAP, to be able to drop a GPU in there and run RAG against your own private company data, it's so simple. And that's where that could, even, again, talking about what is AI, that can be running on hard drives with a relatively affordable GPU on a NAS that you may already have, and now you're taking advantage of this in a private way that is simple and protects your data. That's another big concern, right?
Yeah, I mean, I use this stuff all day, every day to help. It's hard to go back, like, especially for a serial procrastinator like myself. When you just be looking at a blank page for like an hour, you're like, I don't want to start this project, but AI, you're just like, just write me an outline. It's just like get it going. It's so helpful.
Yeah, in that context, certainly it is. It gives you an advantage, I guess a head start. Yeah, if you're having some creative impairment. I know we've talked a lot about AI and these things. These conversations are all unstructured, but that's the thing that's on the front of everyone's minds. Talk to me a little bit about these devices. For anyone listening just to the audio, I'm holding a very tall E1S SSD and a new. You got to. Okay, James.
I've got the two flavors here of this. Is the FADU E1.S. So this is obviously PCIe Gen 5. Up to 20 watts, but most of the hyperscalers are running this at about 16 watts for the 7.68 terabyte and 14 watts for the 3.84 terabyte. Obviously, the 15 millimeter is kind of the more common. You have Meta was like the hyperscaler that adopted the 25 millimeter. It's funny, they claim that like there's a huge difference in the thermal simulations, even that like very very small difference in heatsink, that they see like pretty massive differences in thermal simulations, mostly because the drives are spaced more. But so I think you guys saw WD made a big announcement for the AI data cycle, where they announced their high performance Gen 5 NVMe for training servers and inference and all that, and that's based off the FADU controller and firmware. And I think you can see this is kind of like an early engineering sample here, but I mean, this thing is insanely fast. One of the coolest things it has this new feature called flexible data placement. So we talked about that a bunch. I had a blog post on that, and we we did this like OCP Tech Talk thing. So I was on the panel there. Let's see what's up with my camera here. There we go. I have a really sweet talk on FTP for FMS this year that I'm working on. I talk a little bit about these little crazy experiments I'm running, but exciting. So this, I think, there's going to be obviously this E1.S, U.2, E3, basically, anywhere from 2 to 16 terabyte TLC. It's really for this high performance TLC compute Gen 5, you know.
Well,
But
why? Talk about that for a little bit from the form
yeah,
factor world, because we get a lot of questions and confusion still with the whole EDSFF family. We've seen, I don't know, probably 4 or 5 different iterations in the lab
mm,
here of different Z heights, different shapes, E3, E3 2T,
yeah,
you've got the E1S, E1L. I mean, there's a lot going on there. Has that, in your view, I know you're close with the
yeah.
OCP standards. I know you're involved in SNIA and the other work groups. But do you feel like we're kind of honing in on a
Yeah.
couple that are going to survive
Yeah,
here
you
in
know what?
in the mainstream?
Yeah, for sure. You know, it's funny. I did this update for SNIA. It was like the all things on form factors update for SNIA. I made a joke. My friend texted me. He's like, oh man, SSD form factors. I couldn't think of a more boring topic. But since it's you, I'm going to watch the podcast.
Please, let's go.
I I happen to think SSD form factors are very interesting. But you know, I looked at the spec. You know, the updates to the E1.S spec, like TA 1006. I mean, there hasn't really been very many updates since like 2019. Like we had it pretty much dialed in back then. You know, a couple minor changes. You know, the biggest one was like adding this 15 millimeter because you know Microsoft thought it was kind of the sweet spot for you know, performance and power. And you have like you know, the super micro E1.S system that hopefully we'll have in my lab at some point soon. I don't get sent all the fancy toys like Brian does all the time. We have to procure them the hard way. So,
I
um,
just use blackmail to
but
get ours. It's much easier.
yes, but yeah, you know, the super micro server has, you know, 24 of these in one unit, right? Which is obviously very, very dense, like much denser than you can get with U.2. U.2, traditionally you could get 10 or 12, you know, U.2s in one U chassis. And so obviously having double that, you know, 24 drives, you can get much more performance, more I/O, more. And these things can go, you know, technically the EDSFF drives can go up to 25 watts. You could have basically the equivalent of U.2 performance in a smaller form factor. So, you know, what happened with the hyperscalers is they did exactly what they said they were going to do, right? OCP, you know, Meta has like almost, I think, like 15 designs in OCP that use E1.S. You know, Microsoft has the same, a bunch, like almost every single server, every single new drive that's going into these hyperscale platforms has E1.S. If you've seen, and Brian, thank you for that webcast I did on EDSFF. I stole some pictures from Storage Review for some of these new EDSFF chassis because I don't have them all in my lab.
Sure.
But you know, you have NVIDIA and all the other like Asus and all these other guys doing the NVIDIA DGX that they are now doing with E1.S. And so you have all these training servers that have EDSFF support. As we go into like, you know, E3 was a little bit slower adopter. So, okay, E1.S, just to summarize, the hyperscalers were
Yep.
the main ones using these 1U form factors, right? Hyperscalers were using these 1U servers. They literally invented E1.S for hyperscale 1U use case, and they're doing exactly what they said they were going to do. Every
All
single
right. Well,
design is.
before you go to E3S though, why is it in the latest revisions of hardware for enterprise gear do you think that Dell, Lenovo, HP, etc., didn't do more with E1S since that was already
Mm.
existing in the market?
It's super.
E3S was
Yeah,
built
it's
for
super easy. Yeah,
yeah,
I mean, I was with the folks at Dell and HP when we wrote the E3 spec, right?
right.
I was at Intel and we literally helped them write the spec. You know, they were the lead authors on the spec, and they said very clearly, look, we want one form factor that will work for 1U and 2U.
Okay.
Because at the time, 80% of the volume for the servers was on 2U platforms. So they said, we don't want to do an E1 for, you know, 1Us and then something else for 2U. That was stupid. We just want one form factor that we can literally put horizontally. Now, I actually thought for EDSFF that the E3 2T, like the thicker one, would actually win out because it's more U.2 like and higher power. But they went another direction. Dell and HP wanted to go, you know, with higher drive count per system because they wanted a performance advantage versus U.2, which in retrospect actually was a very good choice because now you have these EDSFF servers that are sitting behind you that have a huge number of drive count for the systems, right? Up to, I think Supermicro Petascale has like 36 E3 and a 2U chassis. That's insane. Like, it's a ton of drives. So in retrospect, like for these kind of storage performance configs, like that was the right choice because you can have the flexibility to go either like you know, 2 1Ts or 1 2T. But you know, E3 is really strong because, one, you have the EDSFF connector. I think a lot of people, the adoption wasn't as fast just because you didn't get all the segments coming over from U.2 right away. U.2 had TLC, it had QLC, you have small drives, big drives, you had all these different, the SLC drives, you had all these different segments, and not all those could have just converted to E3 right away. And then you had, when E3 was started, it was at that point, they were like, yeah, let's not move U.2 to Gen 5, let's just leave U.2 at Gen 4, that way it'll be a faster transition to EDSFF. And then customers said, oh, well, there's these couple tweaks we can make to the U.2 spec to make it the insertion loss a little bit better, and blah, blah, they literally just released the U.2 Gen 5 spec in PCIe SIG like a month ago. it just got out.
Okay.
So, I mean, my preference would have been to just been like, look, we have a form factor that's optimized for Gen 5 and Gen 6. Like, why are you wasting your time? PCI. And at that time at Intel, we voiced our opinion pretty strongly. Like, look, we should be spending our time getting PCIe SIG compliance up on EDSFF because that's going to be the dominant form factor going forward.
Well, I mean, part of the problem is the customers, right? Because you
Yeah.
change things and make them weird. I mean, isn't that kind of why the U.2 drive is the way it is to match up with the 10K and 15K hard
Exactly,
drives
right.
from back then?
Yeah, and then it's funny, right as we're transitioning to EDSFF, Broadcom and HPE are like, let's have this great idea called U.3, and I'm just like, no, God, just stop with the insanity. Like, we have EDSFF, please, everybody, like, let's. So.
Well, U.3 that clearly didn't work.
Yeah,
right?
don't make me get on my soapbox on that one. But anyways, I was very vocally opposed to that. Obviously, people don't want SATA and SAS drives and servers anymore. NVMe, I mean, NVMe is not new, right? We've had the first NVMe drive was 2014. That was 10 years ago. It's not like a new spec anymore.
Right. And the investment in SATA is long gone. I mean, no one's doing anything new there spec-wise, right? And even SAS is being kept alive mostly by hard drives and a couple players that have big investments. But SAS was always hard, and so if you have the investment in SAS, you want to protect that. And
Sure.
I think you were around in the early days when Intel got into the flash business and said, well, we'll take SATA and NVMe, and our development partner was it was HDST back then. You guys can have SAS, and I mean, that seems to have worked out pretty well.
Those are great drives. Really. Yeah, those were great drives. I mean, look, I learned SAS when I was designing JBODs at Sun, like one of my very first job out of college. I know how, I mean, it's funny, once these SAS guys retire, there'll be literally nobody that knows the spec. Like, at least
they've been saying that about mainframe guys and tape guys for a long time, but they still find a way to just.
I know these poor guys. What to say? NVMe is much more organized. It's easy to look at the specs. They're all publicly available. There's no shenanigans. You can just download them on the website. The thing about the thing that they got really right about NVMe, not just the performance and scalable fabrics and queuing and all the other good technical stuff, but the way that they made the spec very open to just be like, you can ask the drive with an NVMe identify controller what the drive supports. You don't ever have to just guess hey, what is this drive? What is it doing? What features does it support? What is it? You can just ask the drive what do you support? It's one of these little thing that nobody talks about in NVMe, but it's extremely useful for software to be able to query the drive and just be like, what can you do?
So we went down a little tangent there. So go back to E3S, and I would argue though that even for server guys that didn't want two different form factors, we saw some early 2U servers where E1Ss were stacked high-low. I mean, it wouldn't have been impossible. I get that they didn't want to do it. And now that we're seeing some of the designs come to market, there's a couple, some of the dense platforms, we just looked at one from Dell, the C6600 chassis, where they just have a couple E3S in the middle. That would be hard to do with the two T1s. It'd be too thick. And anyway, but so go talk a little bit more about.
So the summary is, you have E1.S for hyperscale. That's going good. And now it seems like it's made its way into all these training servers. So we're going to see another uptake in enterprise for these enterprise training servers that are using E1.S. And again, it makes sense, right? It's a small form factor and it's super fast. So And then on the E3 side, it's kind of made its way into these enterprise, platforms. But I mean, even 6 months ago, there was only one Gen 5 E3 drive available on the market you could buy. I think the Samsung one drive was the only one you could buy, right? So it just, there wasn't a huge market, and there was a huge premium, and they didn't have all the capacity points that all the other drives had. So, it sucks as a server manufacturer. They still have to sell U.2, and, so, the transition didn't happen as fast as I would have liked. Of course, it would be nice if all the SSD vendors could just now for Gen 6, hopefully we can be smart and just be like, we're not going to make it a Gen 6, U.2, and then it's only EDSFF, and it's like, so.
No, well, I think, yeah. I mean, I think really there'll be a couple holdovers on Gen 5 for U.2, but most of them are stopping at Gen 4. And Gen 6 has new requirements that are going to make it probably too hard. As to drive availability, you're right. I mean, there was the Samsung part initially. Kioxia followed a little bit. We've got some other stuff that's not public yet, but there's more coming.
Yeah.
So that's exciting.
Yeah, I saw I wasn't there this year at the PCI SIG Developers Conference in June, but there was a slide on the form factor stuff that basically just said, look, there is no plans to develop a U.2 spec for PCIe Gen 6. Please don't ask. Like, if you even think about asking, Brian and I will come find you and do bad things to you. Just use EDSFF. It is better form factor. Obviously, different capacities, different server types, better thermals. I mean, quite literally everything is better about it. So obviously that will, in the Gen 6 timeframe, which it seems crazy, it seems super far away. I mean, I live in the world of strategic planning where I'm thinking 3 years ahead always. So Gen 6 doesn't seem that far away for in my world. But I know people are just in the reality. Customers are just now deploying Gen 5, and
Sure.
they're overcoming signal integrity stuff like you do in every generation, like at the beginning, and then you figure it out, and stuff gets cheaper, and you get retimers and switches, and all that ecosystem stuff gets pretty inexpensive, and then everything just works. So
I don't want to spend too much time on client, but I mean, you're a consumer of storage too, and I know you like to have fun with your projects, personal projects.
Yeah.
What's your take on what's going on the client side? Because that's been way slow on the Gen 5 uptake.
I mean, oh my God, I'm looking at these Gen 5 drives, like even a 2 terabyte can consume maybe, 13 or 14 watts. It's really not the right, M.2 is not the right form factor for like a high performance Gen 5 drive. It's just not. And unfortunately, you're trying to shove, a square into a round hole. There was just this world where laptops and desktops just had to have the same form factor. You must all be M.2, right? And that was where the consumer world, which is so stupid. The priorities on a laptop are battery life and quick performance and bursty performance, where the performance on a desktop or a workstation, you have lots of power. You generally want more faster sustained write bandwidth. People are now not just doing consumer type workloads, they're doing AI stuff. They're moving big data files around. They're not just doing light laptop stuff. In my opinion, those are completely separate segments. An enthusiast desktop drive and a laptop drive should not share any of the same DNA. I think it's so stupid. And trust me, I run any data center drive, and you just put in a desktop and boot it, it'll run circles around any consumer drive in every benchmark. They're just not even on the same planet.
So we're talking about form factor. We got a question on YouTube, or maybe more of a statement. This YJ is saying, I was hoping E32T would make it to consumer desktops because it's a shared form factor for SSDs and other things like PCIe cards. He brings up a really good point, and one that every show we go to, and we talk to Dell about their workstations and HPZ and others. It's like, why are we still trying to jam these M.2s into weird caddies so that we can hot swap them in the front of these things? Why not just go to an enterprise backplane? You could put 8 E1S in there, easy peasy.
Yeah, and you can do it pretty inexpensively, right? You can do, so I know it's the worst name ever, but there is an official PCI SIG Gen 5 and Gen 6 cabling standard called Copper Link, which a lot of people might know as MCIO. But this spec is very good now for cabling Gen 5, and there's ways to do it with SRAS, so you don't need a clock, and that you can have, that was kind of the point of SATA cables. You could have these like super cheap SATA cables. Like, there's no reason why you couldn't do that in a desktop or a workstation and cable PCIe. Like, we know how to cable PCIe, we know how retimers work, we know how this, like, it's not that expensive. I'm sure if somebody's buying a high-end workstation, they'd appreciate a switch card out to a backplane where they can put a bunch of drives in. Like, the fact that I have to buy, the fact that you can buy a $15,000 workstation and you can't even select a U.2 or an E1.S is mind-blowingly stupid to me. Like, I can't even tell you how stupid and frustrating that is.
Well, 15 grand's not even that much anymore for some of these high-end. You throw a couple RTX 6000 ADAs in there at $7,000 a pop or whatever, and a lot of these systems are doing that where they're putting in 2 or 3 or 4. Yep. And then you look at your storage and you're like, well, I've got no PCIe slots left, or if I do, I want to put a high-speed NIC in there so I can get on and off pretty easily. And then you're trying to squeeze and work around a couple M.2 drives, which, as we've discussed already, are problematic. I mean, M.2 is going to have another problem, even in the enterprise when we go to Gen 6 and beyond. That most of the heat dissipation comes through the connector on that thing, right? And to the motherboard, and to get the heat out of that system or out of that drive, there's going to be a ton of problems with heat dissipation with these M.2 drives.
Yeah, I'm hoping some people wake up. I mean, we were, back when I was at Intel and I could actually talk to the platform team about, designs and stuff. That for the whole, what is now the Xeon W, product line. That was called like Fishhawk Falls, I think was the code name or something like that. But we were talking about EDSFF back then, of like at least putting one connector on the motherboard so people could test it and stuff. This was like 6 years ago, right? I mean, I don't know. Like I said, it just unfortunately there's just like zero vision in that market. But I digress. I'm hopeful that we start to make an impact and people start putting EDSFF drives in workstations. It's very clear that consumers and high-end, like people that are on your Discord, these guys are doing enterprise type workloads, or they're building. Like I said, I still work with a lot of these people in the blockchain world who are doing these projects, and like you need to figure out how to get an enterprise drive on a consumer system, and right now you just have these like little adapter cards, and it's not perfect.
I know. I know. We're doing it. We're living it, and it's frustrating. All right. So here's another Gen 5 question for you. Dan Watt wants to know, why do Gen 5 SSDs have poor idle power efficiency? Do Gen 5 controllers have trouble sleeping individual cores or some other thing? I don't know that I've seen that a lot. Have you seen idle power consumption issues with Gen 5 drives?
I mean, it doesn't have anything. I mean, there is something weird, right? Like where anybody who has an NVIDIA card knows this, where if you just leave the card idle, it goes to Gen 1. And then when you like run a workload, it pops out to Gen 4, like these NVIDIA GPUs. And that's not supposed that's not how you're supposed to do idle power management in PCI Express. Like PCI Express has like L1 substates, L1, L1.2, like it has all this stuff defined, and so they're obviously doing that. If I recall, you save like maybe 100 to 200 milliwatts per lane, and so on 16 lanes, maybe a couple watts by sleeping the bus down to Gen 1. Yeah, I mean, so obviously there is some impact there, right? If NVIDIA does this, they're not just doing this because they're stupid. They're doing this because they want to save a few watts. But again, there are other PCIe power states that are like, you should be using, L1. Maybe it has a millisecond resume time, from L1 or something, which is, for a database workload, that's catastrophic. But for a consumer workload, it's a nothing burger, right? You wouldn't even notice, right? So, power. I mean, obviously, I'm in the process of writing a extremely detailed blog post on power efficiency. Hopefully, we'll get some website fixness up by today or tomorrow, and it'll be up there.
So for everyone else, JM writes extensive blogs. He's a really technical guy, and so if you want to keep up with all the, I'm going to politely call it minutia, but there's a lot of detail involved in this, in SSDs, the management, the firmware, how the power states work, all that sort of thing. he's writing that now. He's with FADU. He's got a blog there. We'll link to that also. The blog's having a bit of a moment, but it'll be back
Yeah.
and
Yeah,
have some great
and
content.
you know, I for anything that's not like business topic, I have like a personal blog called ssdcentral.net, which is supposed to just be about stupid SSD topics that people want to hear about. You know that, you know. So yeah, please, like if you guys want me to write about some stuff, it's been fun. You know, mostly I started it because I had a bunch of these random posts on LinkedIn, and I was like, yeah, these should probably like actually live on a website somewhere. So I just started one and put some stuff up there. But yeah, I'm going to be writing for the FADU blog now. We've got some really good stuff. We got one on FTP and one on this energy efficiency and some other good stuff in the pipeline. I'm, as you heard earlier, like deep in the AI world, trying to figure out how I like get all these thoughts into one post. Probably not going to be able to do that. But
no, and you probably shouldn't either, because I think if you try to go, and we suffer from this, if you try to do too much in one piece and you end up with a 8,000 word article, it gets chunky to consume. But go back to FTP, because that's something I definitely want to talk about. I know that you and the FADU team have some leadership position here. This is not a technology that everyone has. So you know, I know, to full transparency, Samsung's there, they're working on it. I know you guys are working on it. After that, it gets pretty unclear. But for anyone that's curious about how the hyperscalers are trying to manage write amplification, and that is the goal to efficiently write to your SSD so you're not overwearing it in terms of endurance, right? This concept has come up before. Most recently, it was called zone namespaces, which was a dramatic non-success, if that's a polite way to say it. But FDP, flexible data placement, seems real, seems like it's something that the hyperscalers are already embracing, which is typically a good sign that it'll happen and come down to the enterprise eventually. But talk a little bit about that, because I know you're really passionate about FDP.
Yeah, FTP is really cool. Obviously, flexible data placement technology. It's almost impossible to understand SSDs if you don't understand write amplification factor. So I mentioned that was like the first blog post I put on my personal blog, was just talking about WAF and over provisioning. Like, okay, so when you test an enterprise drive, you're typically testing worst case 4K random write, and it typically has like a WAF of 5. That's like this JEDEC workload, and this is how they rate the drive in TBW, and that's terabytes written. Not, I see a lot of people writing total bytes written. That is wrong. It is terabytes written, my friends. So like typically, if you the equation is actually extremely simple. Your NAND is rated for a certain amount of program array cycles, you know, paired with an ECC engine on a controller, and you have a certain amount of flash, raw flash on the drive. And so if you want to know your endurance, you just basically multiply the program array cycles, how many cycles can each NAND flash do, times the capacity. And now you have the TBW at WAF equals 1. Now the problem is when you fill up the drive, now the drive has to do garbage collection and move that data around, and it gets hard when the drive is full. And so the more spare area you have, the more over provisioning, the more efficient those garbage collection algorithms get. So if you look at like a 3 drive write per day drive versus a 1 drive write per day drive, those are the same drive. Like those are exactly the same drive. The SSD vendors think you're stupid, so they just make it 3.2 terabytes instead of making it 3.84, because they think people are not smart enough to run a single command to basically delete the namespace and then create a namespace that's smaller. I mean, that's literally it. There's no, you don't even have to do that. You could make a partition that's smaller. You could just write to the certain LBA space. It's all the same thing. It's all just WAF. And so there's been a bunch of technologies over the years to basically see like how can we make WAF better or close to 1 on every single workload. That way you can get the benefits of all the over provisioning without actually spending the money. So basically that's what the FTP is. You can tag the data, and flexible data placement, it's a little bit different than what Streams was, where you can tag the host data with what's called an RUH, or reclaim unit handle, and then the drive can figure out, okay, well, where should I put that based off, based off that tag. The really cool thing about this is it's backwards compatible, so you don't have to have software that's necessarily FTP aware. You can just break a drive up into a bunch of namespaces, give each namespace a reclaim unit handle, and then all of a sudden each workload or each VM doing it to each namespace is just actually has the data contained within that. So the way it's called flexible data placement because it's like logically placed on the flash. Basically, our controller is 16-channel controller. If you look at like a 64 gigabyte die, this is a 512 gigabit die. This is pretty common. You might have like 64 or 128 die per drive. And so the way we do flexible data placement is we have 8 of these reclaim unit handles. Each one is across all 16 channels, and then maybe we pick like 4 die or 8 die. So you basically get full performance on every single workload, but they're completely isolated. And so you get basically better quality of service, you get better write implications, you get better endurance, you get better performance. And so there are some applications that are starting to add like FTP support for tagging. Like you can think about like a file system. This is very simple. It has metadata and has data. It would be very easy to just split those up into 2 streams and tag them differently so the drive knows where to put them. There's a bunch of really simple stuff like that just can dramatically decrease WAF. But yeah, again, like the whole reason why people buy these 3 drive write per day drives is to get higher endurance and better random write performance. But you don't need a 3 drive write per day drive to do that. You just need to get the WAF closer to 1. And there's a bunch of ways to do that for free, not for free. Meaning there's some sophistication needed.
Well, I mean, we talked about this a decade ago when we were looking at the transition from hard drives to flash, or at least hybrid environments. The dream back then, if you talk to all the flash startups, Fusion.io for instance, they were always saying, if we could just make SQL Server aware that it's writing to flash and not hard drives, there's so much efficiency that could be gained by that. But it never really worked out that way because the applications are applications. They're not storage experts.
It's much simpler than that, Brian. Like I talked to a bunch of these developers. Like I talked to the Ceph guys, and these are like all really smart software guys that are like doing hardcore storage stuff. And a lot of these guys just don't have time to learn how these SSDs work, like in garbage collection and trim and like there's a lot of stuff to worry about. It's really that simple. Like unless you're a hyperscaler optimizing these workloads, like typical enterprise workloads, even the databases that are storage centric, like I still see a ton of recommendations online to not mount drives in Linux with discard with trim. It's like, oh my God, this is the stupidest thing on the planet. Trim is the only way an operating system has to tell the drive that the data is not needed anymore. It's quite literally the most important command for an SSD, period. And people are like, yeah, you don't need that. It's because what they've been doing is just over provisioning the drives and letting the drive garbage collection figure it all out itself. And that's just a lazy way of doing it. Like hyperscalers, they're not going to waste 30 or 40% capex on over provisioning. They're going to figure out how to use that storage. And
well, no, I mean they're going the other way, right? I mean they're trying to maximize every piece of NAND and then also handle resiliency there, where if there is a NAND failure or bad die, that they can map around it and continue to use that drive forever until it's totally needs to be replaced.
The way most SSDs do this is just XOR internally between some die. Like if you have a bunch of die, you might have 1 or 2 die in there that it's all XORed together. It's just like a mini RAID 4 on the drive. The ZNS was they had some ideas where maybe you don't do that. Maybe you do this at the host level. But like FTP would allow there's the spec is really flexible. Meta was one of the key authors on the spec, and Google was also another author. So Google's use case looks a lot more like that custom array where you're individually allocating stuff to each die. It's more like a pure storage array or something like that. So Google's idea of FTP is more like that, where you're actually managing the FTL and managing the garbage collection and telling the drive, when to do when to reclaim these handles. Where the meta mode is more of like hey, let's just take an 8 terabyte drive and split it up into 8 1 terabyte drives, and each of them are a little more isolated and are more resilient to WAF and have better endurance and they're both really cool use cases, and I think
Meta can get away with that though because they've got the time and they've got the engineering talent. I guess when I'm looking at FTP, I think it's really exciting, and I think it's more promising than anything else we've seen to address this write amplification issue. But it's got to get easy, and that's where I think it breaks. Is like you need Windows Server 25 or something to be FTP aware and to do some of this, or Ubuntu 2204 or whatever it is that people are running to have an opportunity for it to be aware. And I was going to ask you, I'm glad you brought up.
So that's what my Flash Memory Summit presentation is about this year. I have like a really simple Proxmox example where I have, and this is just done on a stupid desktop I have in my garage. It's not like a fancy server or anything, but I have like this drive here, whoop, and hopefully I didn't just nuke my my screen here. So basically, I have this supports 8 RUH. So basically, there's one command. It's basically a set features command in NVMe CLI to turn on FTP. So basically, you're saying drive turn on FTP, and then there's an NVMe CLI command that basically you can query the drive to say, okay, how many reclaim units do you have? Okay, and the drive says, okay, I have 8, and they're each 14 gigabytes or whatever. And again, the reclaim unit handles map to superblocks that are striped across all the die and all the channel, so they get super high performance. So once you do that, I can go create a namespace and just tag it with an RUH. I can say, okay, this namespace is RUH1, this namespace is RUH2. So I just take the drive, and I just made 8 namespaces. Now I give the VMs, each of those I just map in Proxmox. I'm just giving them a VirtIO namespace mapped directly over in LVM. Each VM gets its own namespace. Now these namespaces, the VMs, each VM is writing to the drive. The drive actually tags it with the FTP tag with that namespace, with that RUH. So all the data is actually physically separated, but the applications are not aware. Like Proxmox has no idea that there's FTP enabled. It has no clue.
Sure.
It just writes the data to the VM, and the VM, basically LVM writes it to VirtIO, and VirtIO writes it to the block layer, and it writes it to the drive, the namespace. But it's physically separated, so you get all these benefits of FTP, but there's no software development needed. And so this is the big difference of FTP versus the other, like ZNS. ZNS, you have to have a ZNS drive. You have to have a ZNS aware file system. You have to have a ZNS everything, or else it doesn't work. And by the way, you can only sequentially write. If you try to do any random write, it just explodes.
Oh,
so
we had a zoned hard drive. We played with that once. It was it was not enjoyable.
I have some too. Yeah.
Yeah. So so you're a controller guy now with FADU. So you guys are engineering the chips that go on the enterprise SSDs anyway, and can do things like FTP. And for you, it's a major differentiator. But you brought up Pure. Why not do less on the drive and do more on in the Pure case of the array side, where they're doing more of that intelligence and flash management in their software versus the drive? Why don't we rely more on host systems and software to do that?
Yeah, I mean, there was like, I remember Kioxia had this like software enabled flash. Like there was at one point where we thought, oh, maybe like the whole storage market goes to these like DIY solutions where there's a bunch of software that does the FTL, the garbage collection, and all that stuff. But I just told you, like, these guys are worried about other problems in application layer, about like data, like the Ceph guys, they're making sure they don't lose your data, and they have to worry about 9 million different drives, like HDDs and SSDs and consumer drives, and like 1,000 different drive models. Like, these guys are not thinking at that level. So no, at one point in time, I think that there was a lot of discussion about like a lot of people going that way. Now, maybe with the Google FTP mode, in the future, maybe there's some open source software that makes this easier, so you can have like a bunch of drives in an array, and maybe you get some benefit there. But this requires a lot of like tuning and application knowledge. And again, like when you do that model, you have to understand how SSDs work, because now you're managing the FTL at the host. You have to know how garbage collection works. You have to know how reclaiming works. Like, you have to know how ECC works. You have to know how like data protection and error recovery and all this stuff. Like,
right.
And quite frankly, just people didn't want to learn that. So it's most of the market is just regular SSDs because it works.
Well, and that's why really when you look at that market, Pure and I guess IBM are the only two I can think of where they're really doing their own flash modules and engineering around that. It's not easy, and they had to be right, or else the company wouldn't exist today.
Yeah.
So it was a high risk effort for them.
Well, oh man, I see a straggler question from Discord that is actually a good one. My thoughts on E1.L. And I was the product manager for the Intel ruler, so we kind of like invented the E1.L. I love E1.L. People think that it's like, oh, it's just like, Intel did a tremendous amount of research before releasing that, showing that is the densest you can get in 1U. right? We had like 1 petabyte in 1U. We demonstrated in 2017, 32 terabyte drives. I think we had powered on in 2017. So E1.L, it is absolutely for like super dense storage arrays. It is unbeatable. Now E3.L, like the longer version of E3, is actually pretty good too. But you have to do one of these foldy PCBs to get like super high capacities. But no, like big drives are coming. People are like hyperscalers are going to be asking for 128, 256 terabyte drives. Like they're not stopping at 64. They're going to go insanely big.
Well, I mean, we're sitting here in early July. I don't have any embargoes that I'm breaking, but I think it's pretty clear 122 will be a topic of conversation in terms of shipping before the year's out. I mean, these drives, the density play is coming quickly. I mean, this is popping fast. So anyone that looks at the pile of 61 terabyte drives we have, they're about to get even larger.
You can send them my way when you're done with them.
We're never done.
I totally want to use them for any project.
Yeah, you want to store plots on them. You chia guy. Go back to the controller though, because this is interesting to me. I think then that historically SSDs have battled out over IOPS and throughput and a couple other things, wear leveling and whatever. But lately it feels like there hasn't been as much discrepancy in performance across the bulk of Ender drives that are quality in any category, right? I mean, they all do pretty well. And we so rarely...
Yeah, it's funny. That couldn't be farther from the truth, right? So one of the things that FADU has is really slick is their 16-channel controller is actually pretty small. It fits on an E1.S and an E3 and a U.2, same controller. So all the other competitors have to use an 8-channel controller to get in the power levels of E1.S. And so obviously right there, like you're not only like better power efficiency because the controller has a bunch of, that's the topic of the blog post about some of the controller tweaks that they've done to basically make it extremely power efficient as far as performance per watt. But we just have a 16-channel controller in a small form factor. So you're basically like 2x the performance on almost every workload. That's not a subtle difference. That's a major difference.
No, 2x is clearly material, yes.
Yeah, and not on when you talk about comparing on a 16-channel versus another 16-channel drive and a higher power form factor, right? The power efficiency starts to matter. Like when you the hyperscalers are getting smart about this, right? If you have like in the EDSF example with the Supermicro chassis with 36 drives, E3, like you're not going to run 36 drives at 25 watts. That's just stupid. Like it just doesn't make any sense. Like you're going to want to run those at 14 or 16 watts. And your power efficiency, if your controller power is lower, then when you start squeezing that power down, hey, I don't want to run it at 25 watts. I want to run the drive at 16 watts or 14 watts. Your performance loss is much less with a power efficient drive. On a power hungry drive, like the other 16-channel guys out there, when you start squeezing that power, you're going to lose like 70% of the performance. And that's not acceptable for most workloads. And so you have this chassis that has all these drives, 36 slots, but you can't even use them because the fans would be at 100%, and you just consume all the power in the server. So these little tiny power efficiency gains, like 2 watts here, 3 watts there, it doesn't sound like a lot, but when you have 24 or 36 drives in a server, it's a lot of power. It's a huge difference.
No, yeah, it's a fair point. And then I guess when you fold in other things like FDP, that can be a differentiator that not every controller supports. What else is there that buyers should be thinking about? I mean, we talked power performance, FDP. Anything else special sauce related that could be a differentiator for the FADU drives?
Yeah, I'd say the way we're positioning it right now, obviously it was designed for hyperscalers, so you get all the benefits of like the open ecosystem with OCP, like the log pages, the telemetry, the you basically be able to do like machine learning models on the output for smart, all that good stuff you get for the monitoring health. I talked about the power efficiency being best in class power efficiency, extremely important metric. Like people should know performance per watt for, again, it's a huge metric in CPUs, right? CPU performance per watt is like a massively talked about issue. Right, so it's I don't know why it hasn't been talked about as much in SSD land, but it is equally as important in SSDs. Obviously, like having best-in-class Gen 5 performance is amazing. So this thing is just insanely fast. And then I mentioned these new features like FTP. It's really cool having the flexibility in these drives to be able to run some of these new NVMe features. And again, I don't expect most people to, be using this stuff, but really the way I'm going to position it in this blog post to be able to enable FTP, create some namespaces. This is not something that you have to be like a hardcore software developer to play with. Like anybody can do this.
Well, it's good stuff. I mean, we're looking at the WDSN 861. That's using the FADU controller in an enterprise drive, and they've got the hyperscale drive too. So that's how this is coming to market. We'll link to that, to JM's blog, to the RAG work we talked about, a couple other things in the YouTube description. For all you guys that joined live, a lot of great comments and conversation. We certainly appreciate that. So if you're catching this on the rebroadcast or the audio only, make sure that you get in on our socials so that you're seeing these things come up live as they go. And
I'm
JM,
hanging out in the I'm hanging out in the Discord.
And check out the Discord too.
Yeah, Brian and I, we're gonna come back and do this with I think some of the WD folks, talk about AI, talk about FTP. We're keep the conversation going. It's been fun.
Yeah, it's been fun. It's the first time I've talked to JM in the last 6 months where he wasn't driving in his Tesla. So that guy loves that Tesla so much he sleeps in it, I think. But it's good to see you sitting down, sir.
A lot of trips to the Bay Area.
We'll catch up.
Yeah, it's extremely hot here right now. I guess I can't complain. There's other places that are pretty toasty right now, so I guess I can't complain that much. But
good. I'll see you soon in person. I appreciate your time. Thanks for doing the pod.
Cool. Thanks, Brian. Later.
Thanks.